Hey, welcome everybody to this installment of the European American seminar series in wind energy. We typically have these the second Wednesday of the month at this time, and we're glad you can be here. Today, Jakob Mann is going to introduce the group that is going to be speaking today.
Thank you very much, Sue, and welcome to this a little bit unusual seminar. It's unusual in several aspects. One is that we are six presenters, so it's almost bound to fail somehow. And the presenters are Jan Dietrich from Fraunhofer IWES, Miroslav Puskaric from the High Performance Supercomputing Center in Stuttgart, Javier Nicuesa from CNER in Spain, and Beatriz Mendes from CNER, Roland Schmel from Technical University of Delft, and me. It's also unusual in the sense that it's not a usual scientific seminar. It's more about data sharing, knowledge sharing, and so that's the other thing. So this seminar is because EU had a call for projects called Physics and Aerodynamics of Atmospheric Flow of Wind for Power Production. And we were supposed to improve wind farm design, choices of location, layout of wind farms, both for energy production and load calculations. So we also wanted to decrease the uncertainties related to these things, and also the durability of the wind turbine. So knowing both the power production and the loads in various situations, especially for very tall wind turbines, even flying wind energy systems. And we should develop models for these, and those models should be used by industry or be able to be used for industry, so they should not be super heavy. And another thing in the call was that we should try to use a lot of data to validate the models, but also share data if that was possible. All the proposals should include at least 2 of 3 subjects: offshore wind, onshore wind, and airborne wind energy systems. In addition, and that's the most relevant here, is that they should develop an open access knowledge hub for experimental data and other data like simulation data and software based on the principles of open data sharing. And that's the whole purpose of this seminar, to kind of introduce this and show everyone what we've been doing so far. So the projects granted in this call were AIRE, which is headed by CNER, Beatriz Mendes; MERIDIONAL, headed by Roland Schmel from TU Delft; and FLOW, which is headed by me. So the agenda for today is, first I do this introduction, and then we have project presentations by the 3 project coordinators, Roland, me, and Beatriz, and they are supposed to last no more than 3 minutes. I've never seen a coordinator of an EU project present their project in only 3 minutes, but we'll try. That leaves us with more time for the meat of the presentation, and that's a data hub where Miroslav will talk about FAIR principles and the WindLab homepage and metadata templates. Jan Dietrich will talk about interfaces and Wind.io, some kind of procedure for exchanging data. And last but not least, Javier will talk about harvesting and a use case. And that should also leave us time for some discussion before we end this seminar at 5 o'clock Central European time. So with this, I'll give the word to Roland. Oh, hi, Roland.
Okay, yes, hi.
Yeah, we could hear you for a short while, but then we cannot hear you.
Can you hear
It's
No.
intermittent.
me?
Yeah.
Okay. Fix this. Okay. Hang on a second. Try something. Okay.
Otherwise, I could start, Roland, if it's...
Maybe you don't.
Okay, I'll start, then you work on the microphone and the presentation. Good, then I'll...
Oh, I think just now it came in. Now it works, right?
Yes, we can hear you now.
Yeah, now we hear you
Okay.
well.
Okay. I share my screen. Okay, too many slides open here.
And then in presenter mode.
Yes, that's what I try. Hang on. I have too many windows open. I think I need to stop shit. Sorry, I have a mess of windows with sharing, and I don't know anymore what to share and what not to share. Let me try.
It's okay. Maybe Roland, Jacob can start, and then you can just.
Okay.
Yeah.
Okay, I can start.
Yes. Yes. Sorry. You have to do that indeed.
Okay, you see my screen now? No. No, sure. Yeah. So
Now we see.
The flow project is an abbreviation for atmospheric flow, loads, and power for wind energy. Yeah, so the purpose is to predict production and loads on tall wind turbines and large wind farms. So the physical processes we are looking at is and try to improve the modeling and understanding of is wakes, of course, turbulence in wakes, inflow turbulence, also stagnation in front of wind farms, so-called blockage, farm-to-farm interaction, so wakes over longer distances, interaction with the atmospheric stratification, so wave generations that also affect blockage, and also interaction with, for example, low-level jets. So that's the physical things that we want to model. So in order to improve models, we need experiments. So the project also contains some experiments. One is fully funded by the project. It's called the Flow Coherence Experiment. And you see a picture here with a number of lidars, and they all look out over the ocean, the North Sea, and measure in several points simultaneously to look at wind variations, how they correlate within a rotor plane in order to produce better inflow models. Another project, which is partly funded by the project, is a test field in Bremerhaven. You see a picture here with a large turbine reaching up to around 200 meters. And in this experiment, we look at wakes and inflow with many lidars and a mast and various in situ measurements. And lastly, we have an experiment which is a continuation of an already existing experiment in the North Sea, where we look specifically at the boundary layer top, because the large turbines of today and tomorrow, they will penetrate the inversion, or can sometimes penetrate the inversion. And we thought it could be interesting to see what kind of velocity differences we see over that inversion and how they would potentially affect loads and also energy production. So that's some of the experiments we have. Simulation software, we do some high fidelity simulation, and the purpose is not that should be used directly in industry, but it should give some data with which we can validate more simple, robust engineering models. And one example is this mesoscale modeling of low-level jet occurrences in the Baltic and the North Sea. You see here the red are a higher occurrence rate of low-level jets, and they appear mainly in this area of the Baltic, and not so often in the North Sea, except close to the English coast. And that has been submitted to a Copernicus journal. Other examples are simulations of wind farms under various conditions, and the purpose is to see how often are these low-level jets important for wind energy production. An engineering model is, for example, the turbulence model we have made, where we see offshore that the distribution of energy in the spectrum is not like the standard says, a nice spectrum with a peak, but it's has more energy at low frequencies. And that we have made a model for that can generate fields that can be used for example, meandering in large wind farms and understanding the loads there. The main point here is probably, and that is to come, is massive validation using OEM data. So when we have done models and engineering models, then we'll validate them and quantify the uncertainty by using the massive data that the OEMs have. And that's how to do that is also quite complicated too. And the partners are DTU, Oldenburg University, Uppsala University, Fraunhofer IWES, KU Leuven, Vestas, Siemens, Gamesa, and DNV and EDF, and Innova is our communication support. But of course, we have plans of validating on Vestas and Siemens data, and also on EDF data, and also maybe DNV data. So that's interesting to see how that turns out. Good. So then I'll stop sharing and hope that Roland, you're ready for sharing. Oh, you should unmute.
You're still on mute.
Still muted.
But now it works,
now.
right?
Now it works.
Okay. Okay. So
Yes.
I think, do you see my slides?
Everything is fine.
And you should also see me, right?
We only see you in the middle.
Okay, good.
Of your slide.
Okay, so I will present Meridional here on behalf of Simon Watson, my colleague, who is actually the coordinator. I'm just filling in today for him, just to point that out. And Meridional stands for Multi-Scale Modeling for Wind Farm Design Performance Assessment and Loading. And you will see that we have one speciality in the project, and that is we do not only look at ground-based wind energy, but also at airborne wind energy. And here you see an example of a kite for harvesting wind energy flying in front of a wind farm. So this is the overall project. It's a large project, exactly like the other two projects. And this plot reflects a bit the setup of the whole framework. So on the left-hand side, we have the Knowledge and Data Hub, the WindLab. Then we have inflow generation is a very important work package. Then validation and tuning together with performance and loading is another work package. And then we have the tool chain integration and test cases as fourth fifth one. And the key points about the project is it's multi-use wind field prediction tools at different scales and fidelities that can be used at different locations. And as I mentioned, for performance, load, and design calculations. We look at unsteady as well as mean conditions, also turbulence, of course. And we look above the atmospheric boundary layer to understand its impact below, onshore, offshore, and up to 1 kilometer altitude. And the higher altitudes we explore with LiDAR, but also by using the kite as a sensor. And we provide rapid assessments or more detailed calculations depending on the needs, data availability, and data accuracy. Now I want to present 3 examples of experiments that are part of MERIDIONAL. And because I'm myself responsible for the airborne part, these will be 3 airborne examples. So this is for one quite unique technique using the kite as a sensor. That's is an extended Kalman filter where the kite is modeled as a 3DOF, degrees of freedom model, and we have an integrated tether model to simulate the sagging of the tether line, which can become important when you have very long tethers. On input, we measure tether force, the reel out speed or reel in speed of the tether, the position and velocity of the kite. And we have measurements for kite power and kite craft. And with these and the extended Kalman filter, we can then reconstruct the wind field at the place where the kite is flying at the moment. And you see here a result of such a reconstruction, including the comparison with LiDAR data that was harvested upstream. So between the LiDAR, the dark blue, and the light blue EKF, there is, of course, a distance of 1 to 200 meters because the flow field's still advecting. And we see quite a good match between the LiDAR data and the reconstructed wind fields here at wind speed itself, wind direction, vertical wind speed also. Then second, moving to loading, we have the challenge that we have companies involved, commercial interests. So we needed to separate the control system software of the companies from the models. And that's what you see here on the right-hand side, where we have a model on the right-hand side developed by our group in Delft, communicating via an HTTP client with the full system software of Kite Power, our partner in the project. And that allows us to fully separate and use the system software as a black box and actually flying our model as a digital twin. And that allows us to have much faster iterations on designs and also test different configurations. And then as a third case, we also look at loads. And here you see a kite set up in the wind tunnel. It's the OJF tunnel of TU Delft. It's a subscale model of the kite. In reality, this kite is 25 square meter, and here it's about 1 to 2 square meter. And we used particle image velocimetry to measure the flow field around the kite here at a relatively high angle of attack. And I mean, then there are a lot more wind turbine related measurements and also CFD simulations, also LES simulations of the atmospheric boundary layer. And all this goes into the WindLab. And this is, I think, where I want to stop, because Miroslav has a much more detailed presentation about that. Just mentioning the partner network here. So you see academic partners, TU Delft, DTU, TUM involved, University of Stuttgart, and we have Polytechnico also, and then we have 3 kite companies, Kite Power, we have Kitecraft, And we have Kite Energy and also Airborne Wind Europe and Icons for Communication, GE and NREL as associated partners. And this is our project management team with the different work package leaders. And I think here I can stop them. Thank you.
Thanks. And then Beatrice, could you share your screen?
Yes. So I hope you see the presentation and you see myself also on the screen. So
Everything works.
okay, so thanks. My name is Beatriz Mendez. I'm AIRE project coordinator. Okay, so I'm going to face today the challenge of presenting this project in 3 minutes. Okay, so AIRE project it's a project that started in January 2023. It was funded under the same call as Meridional and Flow, our sister projects. Okay, and in AIRE we have this consortium, again made of academia and industry. And the main part of AIRE is that we have 8 experimental sites. 4 of them are experimental, okay, and 4 of them are commercial. And we are gathering a lot of information there that will be progressively loaded to WindLab, okay. Blade erosion has a very important role in our project, so that's why we are also measuring precipitation in our sites, okay? In all of the sites that you have seen, we are measuring also precipitation. So our workflow is somehow complicated, but I'm trying to summarize it here. We are gathering data and knowledge in the different sites. We are creating new models, wake models, blade damage models, airflow performance models. With this model, we will be creating wind farm control tools, AP tools to predict power predictions of wind farms, erosion tools. Okay, so all of them with main focus on precipitation and erosion, but also including other effects. Okay, with these tools, we will go to phase 5 case studies, and finally we will improve the components design. At this moment, we are working in the first 3 parts of the project: data, models, and tools. Regarding the data and knowledge hub, we are measuring precipitation, wind and sand particles present in the air at different sites, onshore, offshore, high altitude sites, and also complex terrain sites. And we are also gathering and comparing with the satellite data in order to test how our equipment is performing. Okay, so regarding the precipitation, we have micro rain radar and disrometers. I will explain them afterwards. We have lidars, radiometers, particle aerosols sensor to measure particles in the air, meteorological station. We are also gathering blade status and wind SCADA data, and all of this data is being calibrated with satellite data. Okay, so as a case study for today, I have selected the case study that we are doing in Alaiz. Alaiz is Cener's experimental wind farm. It is located in the north part of Spain, close to Pamplona. It's a very complex terrain site and high altitude, and 6 wind turbines are placed there with 4 met masts also in the wind farm. So this very complex terrain wind farm has also very complex meteorological conditions. Okay, I always show the same video, but it's very visual. So that was September 2023, a very big storm, and all the equipment was there. That equipment is mainly to measure precipitation, a micro rain radar and a disrometer. This equipment measures precipitation with a very high detail from measuring droplet size, fall velocity, and precipitation type. In the case of the micro rain radar, it measures from ground level to 3 kilometers, and in the disrometer, it's measured on the ground level. Some other information is gathered there. We have pluviometers, anemometers, a LiDAR is going to be installed soon, radiometers, and also we are gathering the SCADA data while doing also blade inspections. Okay, so type of data that is obtained from a micro rain radar is this one. I have selected this figure because you are for sure not used to this type of data sets. So we have selected a day. This is the 23rd of February 2023. It was a measure during 2 hours, okay? And we plot here the equivalent radar reflectivity that is used to obtain the droplet size, the vertical fall velocity, and also the estimated precipitation type. Okay, so as you can see, we have a lot of different data with a lot of different information that could be used on many applications. And this type of data sets are the ones that are already uploaded to WindLab to be used. Okay, in this case, the ALICE data set is already there in WindLab. So if you have any other questions or concerns about the AIRE, so you can contact us and I will give you much more information. So thanks.
Thank you. And then we have Miroslav.
Thank you. I will just share my screen quickly. Okay, I hope you can see yeah, both the slides and my web camera. Yes, thank you for the opportunity to present the WindLab Knowledge and Data Hub. So my name is Miroslav Puškarić. I'm a research assistant at High Performance Computing Center of the University of Stuttgart and one of the developers of the data portal. So the objective basically of WindLab was to provide an open access portal for wind energy knowledge and dataset sharing. And by that, we wanted to incorporate the so-called FAIR data principles to ensure that datasets are discoverable and usable by the scientific community, and specifically the wind energy community. And we also wanted to make sure that this data portal can be integrated into simulation workflows. So the WindLab is accessible through the link that you can see in the here in the slide. I will afterwards I will give a short overview of the data portal. So it was basically developed as a joint effort by all three projects. It is hosted at infrastructure at HLRS. It is basically powered by CCAN, open source data management software. So it shows that due to numerous advantages. First of all, it's the large user community. And then there is a support for software extensions, which basically allowed us to install and develop different plugins to address specific needs of wind energy data. Such as showing the geographic location, creating a custom metadata template, and yes, configure the custom search faucets. And then there is also support for harvesting, which allows to collect metadata from related CCAN instances. Metadata is also available in a machine-readable format, so it can be indexed by different academic search engines and so on. And we have also, we are using the taxonomies for describing the data sets with metadata. And we have, at the moment, we are using the three, so need, extract, and aspect, which are developed by the DTU. And are integrated into the metadata template. Okay, now I will proceed with the web page. Yes, basically you can see some outlines of the usual CCAN interface, and we have adapted it a little bit to we have included this picture. And logo and so on. And well, you can see here the search bar where we can search for dataset. We have here some basic statistics which show so many datasets, organization, and groups exist at the moment. So before actually we were able to upload first datasets, we have to create organizations. And here you can see basically all the organizations, so from all 3 projects, and the users, which also have the editor roles, can add datasets to for specific organization. And then further, we have groups, which are basically currently resembles the projects, and we can associate, perhaps for better visibility, data sets with each of the projects. So then we proceed to data sets. So what we did, where we modified the CCAN a little bit, was with this, for example, these search faucets here. So we can, instead of tags, we have topics, external conditions, and variables. So we can basically narrow down the list of data sets based on these parameters. And so, for example, in as Roland already mentioned, the focus of MERIDIONAL is on airborne wind energy systems. So if we click on this airborne as topic, we are now have a list of 2 data sets maintained and uploaded by the TU Delft. And you can see here some description and the other metadata, such as subject, or those that I mentioned before. And also this map, which shows where the data was acquired. So then I can perhaps show briefly how the data set is created. Perhaps to just put more emphasis on user-friendly approach to putting metadata, we have here configured the tags, which are predefined, and we can, for example, if we start writing wind, we are now offered with some options, which actually come from the NEAT taxonomy. Wind turbine, we can then add multiple of them, multiple tags, and then the same is basically for external conditions and for data set variables. And the spatial data is added in the end. And then if we okay, so the next step is basically to add the actual files, which can be either a file, the actual file, which is uploaded to the server, or a link which points to a different, to other source. And then just for the end, I would like to explain also the harvesting quickly. So we are actually we harvest the content of the CCAN, which is maintained by the AIRE project. Basically, this is the data set which is also found on their CCAN and is listed here. And yes, so this is basically the source. Yes, I leave the rest of the details to Xavier, who will also provide some information. So that would be all from my side.
Thank you very much. And then we have Jan Dietrich.
I'm just trying to share my screen.
Yeah.
Is that visible to you guys? No.
Everything works fine.
It is. Awesome. Awesome. Thank you. So my name is Jan, and I'm just going to give a couple of slides based on the Knowledge Hub and the data that you can find in there. So first on the Knowledge Hub. So as we said previously, look, we're going to try to we have 3 projects, and we want to basically use one database for that. And the idea as well in the project is that actually the database, what's in there, is for the public, the industry, and the researchers, okay? So focus is as well actually the public, minor, but still. And so the data we want to store on there is the model data, experimental data, but also, as some of the others already touched on, is actually model chains, processes, and also publications, because we want it to be a center for the analysis, for the knowledge in respect of wind energy. So we have several of those types of data sets in there. The first one is just a quick one, a couple of examples. We have on the left a modeled data set, which is the LES data set from KU Leuven, for example. And on the right-hand side is just a snippet from the experimental data set from Bremerhaven. So there's two data sets. But that model we have in there as well is actually, in respect of the processes, model chains, or processes more is actually Jupyter notebooks as well. For sure, you can't run them through the interface of the WindLab itself, but you can download it and then run it yourself. And you can then also basically query for other data sets that might be on the WindLab, and it's going to be all connected. That's the idea behind it. Publications as well, because you're going to have this interlink between data sets and publications and processes. So it's all this sort of basically one-stop shop. One thing I would like to mention here as well is that there is quite a bit of metadata behind the scene, and we're sort of querying that beforehand before people are uploading any data sets. It's pretty much based on three things. So it's the first thing is basically what's sort of there in the data site environment, author, title, where can you find the data, and so on. Then another block information we feel is needed, sort of more just sort of at first glance, what kind of temporal resolution, temporal averaging, or when did the data set start, and so on. That sort of you will see. And on the last bit as well, just a very quick overview in respect of the data sets that have been uploaded. So that's sort of in a small README file for each data set, which is nice. The other thing I just want to touch on as well is basically machine actionable data. So for data sets, it would be fantastic if they had the same format. For some of our data sets, we are actually going to use WindIO schema. That's specifically interesting in the Flow project. But what I'm going to show later on as well, it's not just going to look at the WindIO. You can select other schemas as well. But I'm just sort of saying, what we're trying to achieve as well for the modeled data, especially in the Flow project, that they follow a certain schema so you should know what to expect. Miroslav has already basically given some slides on and the demonstration on the interface. So we have the WindLab interface, but what I'm actually working on is the API for this. So for CCAN, there's quite a good documentation on the API. And what we are trying to achieve is actually do a Python module called WindLab, in which you can use with setup files or other settings to actually upload data to search the WindLab database. And that's what we're currently working on. And it's going to be a proper Python module with tests as well. It's going to be sitting on the GitLab and so on. So what I'm going to do very shortly is going to do a quick live demonstration of that API call. I have a couple of setup files. The first one is, I'm just looking for any data sets. And the second one is basically where I have a query. I want to just see all the data sets that contain something like test Jan. So here, this is now, you guys can still see my MS Visual Studio. I let the first one run, and the first one was just basically just querying all the data sets that are currently sitting on the WindLab. And what you guys can see is we have 18 data sets, and I'm just sort of presenting here in a very unstructured form, but as a YAML construct, predict the information that's being held for the first data set. Whereas the next call I'm just going to do here is where I'm just sort of querying, where it's sort of queried slightly. I'm now looking for data sets that have something called test Jan. And so there we have two data sets, and now I'm just sort of presenting some information on the first data set. So that is basically just a couple of examples I wanted to show you on the API. And look there, then you can query as well. The API is there to basically search the data set, what is there. It's there to read data from it. It's actually, the API can be used as well to write data and even to delete data. Maybe not everyone gets this functionality, but that's what the API is for. And the other thing I just want to mention as well is in the WindLab, there's going to be, I guess in the end, two types of data. there's going to be data actually uploaded to the WindLab. But what the WindLab is supposed to have as well is information on data sets that already have been published somewhere, like on Zenodo, okay? And so the data set as such is still mentioned under WindLab, and we have a link then in the data set and the resource, and it would direct you directly, for example, to Zenodo page where the actual data sits. So we don't duplicate data, but you still can find it through the WindLab, which is the idea behind it. And again, when you're actually uploading data, there's going to be a need for some standard documentation, and you can do some testing in respect of Wind.io, for example, or any other schema tests. For sure, this is still progress, and we sort of know there's some further improvements we need to do. So restrictions on the upload, for example, that the GitLab, that the Python code needs to sit in the GitLab. For example, when you query data, that you can specify date ranges. It would be really nice that it has a better documentation, and as well that from the data that's being supplied, that we can actually have some automated generation of key value pairs for the WindLab database. And that was it from my side.
Thank you very much. Then we have Xavier.
Yeah, hello, good afternoon. Let me share in my screen. Okay, I hope you're seeing it correctly.
Yes, it works.
Yeah, okay, thank you very much. Okay, good afternoon. My name is Xavier. In this last part of the presentation, I will introduce you a couple of topics about the Data Hub, which is how to add data sets to the Data Hub in CCAN, which are the ways that CCAN allows users to add the data sets. And I will present, or as use case of the different formats that CCAN accepts as data set, I will present a use case from AIRE, which is the precipitation data that we are collecting in the AIRE project. So let's start adding data sets. We have a couple of ways of adding the data sets. One of them is the manual one. Do it manually. Data set, we need to understand the data set as a kind of object that CCAN is using. It's composed by usually a file, a description, and more information. All together compose the object that CCAN aims as data set. This data set is, as we have seen in the examples, is what usually is going to find when searching for data in the Data Hub portal. This description with another more information like tags, organization, visibility license, depending on how the form is created, altogether creates the metadata, which is the information describing the data that it's going to be located in the Data Hub. This all metadata is going to, in this manual way, is going to be introduced by the users in a very easy, user-friendly way, using the form in the user interface. So once we have created this data set object in CCAN, probably we want to upload the resource. The resource is typically the file. I mean, usually here we talk about the data files, but as Jan said, it's not necessarily only data files. It could be any file related with the data set. Could be, I don't know, maybe a paper explaining the circumstances of the environment of how this data set was achieved. So there are two ways of uploading these resources, these files. One of them is just clicking on the upload button, in which we'll just have to select which is the file that we want to upload. This file have to be in our local storage system or at least mounted in our computers, we have direct access to these files and we can upload it. And the other one is adding a link to another remote location. Here I have used a Synode example, but of course it could be any web server which has an open access or maybe not open. Then we can use an API for accessing it, but at least must be a web server where CCAN can access through or via HTTP. Okay, then here we have the second way, kind of semi-automatic way of adding these data sets to our data portal. Harvesting is defined as this, as the technology providing this option of adding at least metadata. Probably we would like to add data too from other catalogs or for only other portals into our data portal. Harvesting by itself is a kind very similar to the ETL process, the extraction, transformation, and loading of these data sets. We are dealing with data here. The data in our case is the metadata, which is lighter than the normal data, but it's still data. So the process of harvesting is an ETL process. In our case, we are using the version 2 of CCAN. So we are using the CCAN Next Harvest extension. You can find all the information about this extension in GitHub repository. All the documentation and code is free available at this repository. CCAN Next Harvest builds its own ETL system, which means that it has some advantages and some disadvantages. The advantages are there. It's very easy to set up the harvesting process via CCAN. It provides a form to set up the harvesting. It's like the forms that we have already seen. So it's very easy, very user-friendly. And the disadvantages are that it's developed in a very tight to code. It's not taking advantage of the API of CCAN. This is still not developed from the philosophy or the strategy of microservices. It will be. Hopefully someday it will be. And well, it has its own runners instead of having in a more standardized format like would be Airflow. For the harvesting, we need to define which is the job where CCAN is going to run. It's funny because being so user-friendly interface, the option is not available through any menu option. We have to type the address in the address bar of our browser, then the form will appear. Basically, we just need to add which is the URL from the remote CCAN from we want to harvest the data. That's all we need to do. Of course, probably we will like to add some description, the frequency of the harvesting, and the main important thing, main interesting thing is that we can set up more or less a little bit how some actions are going to work. In this case, we can, in this configuration text box, to specify in a JSON format, which is the API version that we are going to use in the harvesting, how to work with remote organization, remote groups. We have the option of creating the remote groups and organization if they are not still in our data hub, or maybe we can tell the harvesting only to harvest data sets from an organization that already exists in our data hub. We can specify who is the user performing the harvesting, an API key in case the data set of the remote data hub is a private data set. We can add a flag of read-only data set to be sure that this data set is not going to update for anyone. And we can use some filters on the harvesting to include or to exclude some organization or groups from the remote data hub to be harvested into ours. Now, let's see the use case about the precipitation data collected in AIRE project. We have chosen two kinds of formats, more or less about the precipitation data to show how we can add data sets with a very simple data, which this is the case, in a comma-separated value format. We have a meteo equipment with a pyranometer and a pluviometer. So we are collecting data of the total rainfall and data from global horizontal irradiance in 1 minute and 10-minute aggregated the values. So very simple structured files. So probably we got so many of them. And then we can find some more complex structures. In our case, I'm presenting here the distrometer and the micro rain radar, in which it's not just a simple plain table or matrix, but more complex structures, taking advantage of the dimensions of NetCDF format. So we have in the distrometer, for example, we got information about the raindrop sizes and the velocity in beans, 32 beans for size and 32 beans for velocity. And in the case of micro rain radar, the beans are 128, 25 meters each bean, and we got information up to 3,200 meters from variables like Doppler effect, noise ratio, reflectivity, drop side, rainfall, etc., etc. And that's all from my side. Thank you very much for your attention.
Thank you very much, Xavier. And now we are going to the discussion phase. So if anyone have any questions, then please step forward.
Hey, Jakob, do you want to have a look in the chat? There's been several questions in there already.
Well, I think there have been answers, partly at least.
Oh, yeah.
It's Andrea McCurdy who writes, is there the inclusion of ocean collected wind data? And yes, there is several sources. There's some from MERIDIONAL. I don't know if Roland, you want to explain what that is?
Yeah, I don't know the specifics, but I know that we have several projects on offshore.
Okay. And in Flow, they are not uploaded yet, but we will upload the data of the coherence experiments on the west coast of Denmark, and we'll also upload the boundary layer height data from the experiment in the North Sea. So there will be a lot of data.
Yeah, maybe let me add. I think in Meridional, I think most of the self-harvested data is from airborne devices, which is a new technology, and we have access to commercial projects that harvest this data. The more tricky part is to get, let's say, wind farm and wind turbine data. So with this, my colleagues struggle from the wind turbine department. But I think the idea is to upload something or make something available.
Sue?
Just to clarify, is this database only going to house data from these 3 projects, or are other projects welcome to upload data that might be of similar interest?
Jan, can you answer that?
So actually, one of our requirements are to upload new data sets, but another requirement as well actually have the knowledge of existing data sets in there already. So if you have old data sets that haven't been published yet, or you just would like to sort of put out more to the science community so that more people find out about it, so they all could go in there. We haven't decided yet or thought about if other people actually would like to have absolutely new data sets, which are, for example, not going into the A2E or whatever, if they could come into the WindLab. In general, you know, the more data sets in there, the better, because then it makes it even more a one-stop shop. However, we haven't actually really thought about it. Sue, I have to say you're sort of the first one to raise that question. So thanks for that. And we'll actually think about it.
Okay, great. Thank you.
More questions? Nothing in the chat either. Okay, good. But then I'll thank the presenters and also thank you for keeping the time. So then we will upload the presentation soon in a couple of days from NCAR at the NCAR website, and we are looking for other presenters for future seminars. We have a seminar every the second Wednesday of the month, every month. And if you have something that you want to share with the community, then please contact either me or Sue Ellen Haug. So with that, I'd like to thank all the presenters and all the audience for joining this presentation. So, thank you very much.
And thank you all for the great webinar today.